So we're going to pick up where we left off last time. If you recall, our earlier lesson last time was talking about the structure of the QuoteServices app case study with respect to refactoring or factoring out the code to avoid repetition for the different microservice implementations. We're now going to talk about those microservice implementations, starting with the Handey Microservice implementation. And we'll start by talking about its structure and functionality, and then we'll actually walk through the code. So we're going to take a look here at how the Handey controller and the Handey service classes, as well as the Handey application, are implemented. And just for fun, we're going to use the project Reactor mechanisms for Flux and parallel Flux, which uses so-called reactive programming and reactive types. This is a little bit of a teaser for things we're going to get into here shortly as we get into the next part of the course, which we'll talk about reactive programming. So we have a Handey application class, which is the entry point into this Spring WebMVC based version of our Handey Quote microservice. As you can see here, Handey application extends base application, and that's the base class, the superclass that defines the run method that will be used by both Handey and Zippy applications, just factoring out common code. We make this a Spring Boot application so it can run with all the component scanning and dependency injection and auto wiring and so on that Spring provides. And then here's the main entry point. And as you can see here, this goes ahead and calls the run method that's inherited from the base application, passing in the things it needs to do, and that will start up and running the microservice. Pretty canonical. We'll talk later about other interesting things you can do with this kind of capability. Let's now talk about the controller. The controller is ridiculously simple because we've factored almost everything into the superclass, the base controller. So the Handey controller is going to receive the get and post requests, and then they'll be automatically mapped into the things defined in the base controller. And then those are, as you may recall, going to forward to the base service, which will be the Handey service in this case, of course. And we'll see how that works when we take a look at the Handey service momentarily. One thing to note here, this controller is going to be parameterized to return a list of quotes. This is just classic Java types that are returned here. If we had wanted to, we could have had it return reactive types like a Flux. And one of the nice things about refactoring the code the way we did is we could move seamlessly between using list types, which are the kind of classic Java types, versus the more modern reactive types. So we've arranged the code so it can be parameterized quite easily. We use the REST controller to make sure it can return serialized objects using HTTP response capabilities. Again, nothing new there. Let's talk about the Handey service. This is kind of fun. So as you can see, the Handey service is going to actually define the implementation methods that are forwarded to it from the Handey controller, which in turn inherits those from the base controller, once again applying the do not repeat yourself principle. By implementing base service, we get a set of interfaces that we're then going to fill in, and you can see that that's once again parameterized by a list of quotes. What's interesting about this particular implementation is that the implementation of the methods use reactive programming and reactive types, but then at the very last moment, we convert them back into classic Java types. And the reason for that is that we haven't gotten into WebFlux yet, which would allow us to return the reactive types. We will get there shortly, but for right now, we're keeping the interface using the classic Java types, even though the implementation is going to use reactive programming. So this is kind of a hybrid implementation. This just says this is a service that can be auto-wired and auto-detected and so on. We auto-wire one field here, which is this quotes field, and this is what stores all the Jack Handey quote objects in a non-persistent list. And what that means is that when the program starts up, because this is an auto-wired field, there's a bean that will create a list of quotes, and here are some of the quotes from Jack Handey. Jack Handey has all these very sort of wry, gallows humor kinds of quotes, like, to me, boxing is like ballet, except there's no music, no choreography, and the dancers hit each other. So if you've ever heard of Jack Handey, he's known for these crazy quotes. Here is one of the methods. We'll look at the other methods later. This is the post quotes method. It takes a list of quote IDs, which corresponds to the elements in this list, and it returns the corresponding quotes from that list. And it does it using Project Reactor Flux and parallel Flux types. Now, I'm not going to go through this in great detail now. We will talk about this stuff in much more detail later. But in a nutshell, we take the quote IDs list, we turn it into something that's called a flux. Then we turn that flux into a parallel flux. And then depending on the parameter here, parallel, we either run this in a pool of threads or in a single thread. If it's a parallel parameter is true, then we run it in a pool of threads. Otherwise, we run it in a single thread. We then go ahead and look up every one of the elements by their ID in the list. We convert that back into a sequential result, collect it into a list, and then call the block method. And the block converts this from a reactive type back into a classic Java type. So we end up with a list of quote objects that will come back from that. This logic here can be realized in a much more parsimonious way in parallel streams, which is almost always the case. Parallel streams is almost always shorter and often as performant as the reactive programming. We'll talk in a second why you would ever want to use reactive programming in a minute. But this is the corresponding Java streams version where we take the quote IDs, get the split iterator from it, and then either in parallel or sequentially turn it into a parallel or sequential stream, get the various elements, and then convert the results back to a list. I think you'll agree that it's a lot shorter and more parsimonious than the code here using Flux and parallel Flux. The main reason why this is more convoluted is it's actually capable of doing a lot more things than streams do with respect to asynchronous programming and reactive programming. So the penalty for that is there's some more ceremony going on here for the reactive implementation. When we actually start talking about reactive programming, you'll see that you can do a lot of really cool things with it that you would have a hard time doing with streams or parallel streams without combining them with completable futures, and then it becomes complicated in a different way. So just a quick sort of Rosetta Stone comparison between a couple different approaches. So that's the end of the overview of the Handey microservice structure and functionality. We will now walk through the implementation quickly.